Welcome to Homework Lib.
This is chapter 35, problem number 24. The problem is about to reduce the glare when people are viewing the artwork. So let's draw the mediums. First we have air, and then we have the titanium dioxide film that has index of refraction of 2.62. And then finally we have the glass, 1.62. So we have three different mediums. And we're asked to calculate the thickness of this titanium dioxide film in order to decrease the glare. So let's look at the reflection from the front of the film, right? So as it reflects from the surface, it's going to undergo 180 degrees phase change. As you know, when the light goes from a lower index of refraction medium to a higher one, as it gets reflected, it undergoes 180 phase change. So then a refracted beam from the back of the thin film, titanium dioxide film, is also going to reflect back. However, it won't undergo a phase change because here on this boundary, 2.62 is greater than 1.62. So then going back, actually no phase change, which means the overall phase change between these two 1 and 2 beams, phase change is 180 degrees. So when that's the case, then in order to have the destructive interference, because we want to reduce the glare, then our condition is going to be 2t equals m times lambda being lambda in that particular medium. So lambda for our case is going to be initial lambda divided by the index of refraction of the film. Now we're trying to find out the thickness. So thickness is going to be m lambda over 2. Plug it in for the lambda in air, m over 2 lambda naught and film. So then when we plug everything in here, m is going to stay, right? We're going to look at the orders. So lambda is 505 times 10 to the negative 9 meters divided by 2 times 262. So what we have here is 96.37 times 10 to the negative 9 meter times m, which means the minimum thickness that is asked in part A, it has to correspond to m equals 1, which means the thickness is going to be then minimum 96.37 nanometers, right? This is the answer to part A. Now in part B, we want to discuss the next three thicknesses, like the thinnest film. So then they will be corresponding to m equals 2, right? So then the thickness would be the twice of this from this equation that we just derived. So twice that would be 192 times 7.5 nanometers. So m equals 3 would be 3 times this number, 289, 12 nanometers. So m equals 4 would be thickness corresponding to 385.5 nanometers.